Hello everybody and welcome to program 123 again. Today we're going to be analyzing the problem 1 of US Open Contest 2020 bronze category. So it's basically that we are given a binary string which is formed by at least 2 zeros, and our task is to turn 2 of those zeros into 1 such that the minimum distance between any two numbers 1 is maximized. So since there will be at least 2 zeros in the string, it will be always possible to turn 2 zeros into 1, and we must do it. We cannot avoid turning 1 0 into 1. Okay, so we have this example test case, which is a string of 14 length 14. As you can see, in the original string, without converting zeros into 1, we have a minimum distance of 3, which is in this two numbers 1. So we have a distance of 1, 2, 3. But once we add the two numbers 1, once we turn 2 of those zeros into 1, we obtain a maximum distance of 2. 1, 2, 1, 1, 2. It's the maximum that we can get. We cannot place this number 1 in any other way such that we obtain a greater sum. Well, there are some cases of interest for this problem that we gotta take a look at, which are these ones. The case in which we have all the string equal to 0. The case in which most of the zeros are at the beginning of the string. In this case, we have to place 1 1 at the beginning and 1 1 at the end, and the distance will be n minus 1. In this case, we have to place 1 1 here and the other one in the middle. In any of these two positions will be okay, and we will get the maximum distance. And the opposite case, in which we have a lot of zeros at the end of the string, and the other case in which there is a big spot among the string in which we have to place both number 1s. This other case in which we have to place 1 1 at the beginning and 1 1 at the end. This other case in which we can put the number 1s at the beginning, in the middle, or at the end of the string. This other case in which we can place the number 1s optimally, and we do not affect the original layout, the original arrangement of the string, because we can place 1 1 here and 1 1 here, and that doesn't mean that we are going to get a distance of 1, 2, 3, 4, let's say 4 or 5. No, we're not going to get a distance of 4. We're going to get a distance of 2 because it was constrained by the original setting, by the original arrangement of the string. So even though we placed the two number 1s optimally, we didn't get a less distance than what we had previously. Now the other case in which we have to place both 1s in different spots, but these spots are not at the beginning or in the end. They are like in the middle of the string. Let's consider all these cases in our code. Let's see it. Okay, you guys, here we have this code, which is the solution for the first problem. So I used to comment these two lines when I am trying my code, because I want to use the standard input and output. And if I uncomment them, then I'm going to be reading from these two files, which are the ones that the problem requires us to read from. let's comment them again so that we can try our code. Okay, so first we read end, which is the line of string s that we are going to read later. Let's declare these three variables. This variable is going to count the number of zeros at the beginning of the string before finding a number 1. The same for this one at the end of the string, and this one is going to be counting the segments of zeros, of continuous zeros in the middle of the string. Okay, so let's set all of them to 0. Let's use a priority queue to always get the biggest spot to place our number 1s, and let's count the number of zeros at the beginning. We make sure we don't surpass value of n, and we increase the values of f and I accordingly, And if we surpass the value of n, it means that our string is formed just by number zeros, and we have just left printing the distance, which is gonna be n minus 1. You can try this paper, test this code against a string formed by only zeros, and you will see that the greatest distance you can achieve is n minus 1. Now let's decrease our variable n so that we can see the number of zeros at the end of the string. We are sure that we are going to find a number 1 here. We're not going to have an n less than 0, because we made that sure here. So we know that we're going to get to a number 1 sometime. So we don't have to do short circuit sequences like this, for example. We don't have to do that because we are sure that there is a 1 in our string. Okay. Now that we have counted the number of zeros at the beginning and at the end, let's count them in the middle of string. And if we find two numbers that are continuous, then we're going to print. We're going to print 1, which is the minimum distance that we can achieve. And if we don't find two numbers 1 that are next to each other, then we're going to put our count variable in the priority queue. And let's reset it so that we can start counting the number of zeros in another segment. We're going to have two variables that are going to help us identify the greatest distance we can achieve when placing these two number 1s. If our priority queue is empty, like in this case over here, we're not going to have anything in our priority queue. These zeros are going to be counted in the variable f, and these zeros are going to be counted in the variable L. So we're not going to have anything in the priority queue. So in that case, our variable temp is going to be equal to 0. In any other case, let's get the greatest element, and we're going to calculate the distance when we place both of these number 1s in just one spot. So when we place them at the end of the string, when we place them at the beginning of the string, or when we place them when we place them in the middle of the string. Okay? Now that we have calculated that, let's compute when we place both of these number 1s in separated spots. Okay? We're going to ask if the zeros at the beginning of the string are more than the ones at the end of the string or in the middle. Then we're going to set our variable d2 equal f, and we are going to say that there are no more zeros at the beginning of the string because we have already placed a number 1 in the very first element. Why am I doing this operation? Well, when you place number 1 in a segment of zeros that is surrounded by two number 1s, then the greatest distance you can achieve is the Halim function of the length of that segment divided by 2. You can try that on paper if you want to. Okay, so when the number of zeros at the end is greater than the beginning and greater than the number of zeros in the greatest segment in the middle. Let's do something similar, and when we have the greatest number of zeros in a segment in the middle, well, we assign d2 equal 10, and let's extract that element from our priority queue. Now let's make a similar process. Just that this time we are going to ask for the minimum. We're going to use the function min in order to get the less of these two values. Okay, now we're going to compare. Is greater the distance that we get when placing the both of the number 1s in the same spot or in different spots? This is what this line does, and we're going to compare this result with the original arrangement of the string. We are going to empty our priority queue, to get to the lowest segment of this string. This while cycle is going to work in a case like this. We have placed both zeros optimally here at the end of the string, but actually the minimum distance between any pair of ones is the one that we have here. So we have to ask for that distance. That is what this cycle does, and we have just remaining printing the number, the minimum distance between any two number ones in the string. Now let's try our CAD with the test case that Usako provides us, and you see we get the same answer, which is 2. And now when you submit this code, well, you get all the 15 cases accepted. So that's it for today, you guys. I leave you the link to this problem in the description. Thank you for watching this video. I hope you like this and share with the ones who need it. And remember, stay home programming, and goodbye.